Hi, and welcome to our discussion of folds. We're going to talk about fold anatomy first, different styles of folds. Ultimately, folds typically result from compression or some kind of shear stress, but compression is usually the most common, or at least it's where the deformation starts out. And in this case, we have a pretty basic set of folds here. This is an anticline, I'm highlighting. Then we have a syncline, and then we have another anticline. Okay? The folds have different parts. We have a straight bit here and a straight bit there. That's called the limb. And then we have the curved area. That's called the hinge. Okay? The hinge line is the spine of the fold. It's the point of maximum curvature. I'm just drawing it right now. It's all of these little black lines. And you can see each layer here has one. Okay? If we connect all the hinge lines up, which has been done here with this blue thing, we call that blue thing, which is an imaginary thing. It's called the axial plane. So it's a plane that passes through all the hinge lines, and essentially what it does is it bisects the limbs of the fold. It cuts the fold in half. Okay? In this case, for a anticline, the limbs dip away from the axial plane. Okay? Notice here the dip is down like this, sloping down like this, so it's dipping towards the axial plane. Here's the anticline, dipping away from the axial plane. Now there's another thing to keep in mind here. Remember the principle of superposition. If this is rock layer 1, 2, 3, and 4, the oldest rock here is in the outside. If I was to cut through here and sort of erode through it and then walk over it, this rock is the oldest, and this rock out here is the young. Oopsie daisies. Well, it cleans it up for you anyway. Sorry about that. This rock here is the oldest, and this rock is the youngest. So in an anticline, as you move from the axial plane away, you go from old to young rocks, right? This is 1, 2, 3, 4. Okay? Then we go from old to young again, right? Old to young here. Now, for the syncline, we're going to go from young. Okay, as we walk away, things get what? Older, right? We go from young to old, and then we're back into an anticline, and we go from old out here, or in the middle, in the core of the fold, and the hinge of the fold, to young, right? So that's important to remember too. It's both the geometry of the structure and the age of the rock layers in it that tell us the kind of structure it is. Anticline goes from old to young, layers dip away or limbs dip away from the axial plane. In the syncline, the rock layers near the axial plane or in the core of the fold, we go from young to old as we walk away from it, and the layers dip towards the axial plane. Okay? Here's a map, a geologic map. Now, here's a map that's simplified from the maps I've shown you in previous segments, and that's a good thing, I think, for everyone involved. But what you can see are some symbols. Look at your strike and dip symbol here in dip direction, strike and dip symbol here with dip direction. This is the fold symbol for an anticline, okay? And you'll notice limbs dip away. Notice the dip direction as we come over here. Dip direction is the other way. Limbs dip away in that direction. Now check out these dip directions. Here dips in to the left. This one's down dipping to the right, right? So here's the fold symbol for a syncline, right? And then for, I already drew it here over here, your anticline, okay? And on the top you see the map pattern. So the pattern that you see at the Earth's surface that I would draw on a map is shown or projected from the irregular Earth's surface up to a flat two-dimensional plane. And so when you look at a map and you see all these great colors and they all have these kind of interesting patterns, that's because the rocks have these kind of interesting intersectional relationships with the Earth's surface. So basically the rocks are tilted or deformed or rotated, and then we've eroded through those rock layers and we get an interesting pattern. Okay? Now, fold, we can mess around with the syncline and anticline. Here we have a bunch of syncline-anticline combos or pairs. Okay, and let's look at the basic style here on the top right-hand corner. Okay, so we see the syncline, anticline, anticline, syncline. Notice the axial plane is drawn for us right here. It is vertical. Notice the limbs are the same length on both sides of this. This is called an upright symmetric fold. Okay? It's symmetric because the limbs are the same length. Okay? Now, come over to the left and you notice the axial plane, which bisects the fold in half. It's shown there, it's shown there, is tilted or rotated. We have a long limb right here, and we have a short limb here. Okay, so the long limb goes all the way down like that. Okay, and the plane is tilted to the right. We call this fold, because the limbs are different lengths, we call it an asymmetric fold. Okay? So an asymmetric fold has a tilted axial plane, and one limb of the fold is going to be longer than the other. If we continue to stress the rocks, right? So the primary force here is probably compression. Shortening is the strain. The force is compression. The strain is shortening. If we continue to do it, what's going to happen is we're going to get some level of shearing, and shearing is going to start to rotate this axial plane, right? To rotate the axial plane, we need shear stress applied to the system like this and like that. Okay? If we keep shearing it, right, even further, we get more shearing going on. We're going to rotate the axial plane. We're going to have an asymmetric fold that is now overturned. Now, what is the part of this that's overturned? Well, the part of it that's overturned is in the short limb, which is here. So here's long and here's short. And it's the rocks in the short limb are now upside down. I can draw an over-exaggerated version of this, right? This is up, okay? In these rocks, this is the up direction in those rocks. They've been flipped upside down, and so that's what overturned means. Take a minute, let's look at this fold. Okay? You may want to draw it or sketch it. I want you to tell me, is it symmetric, is it upright, is it overturned? You might try to sketch it out and identify the limb, the hinge, the axial plane, the axial surface, or the axial traces. Okay? You might just go ahead and pause for a second and then come back to it. All right, let's walk through this particular answer. So here's a limb and here's a limb, correct? Limb and a limb. This is the hinge of the fold. Okay? Limb, hinge, limb. Here's axial trace coming out, axial trace, axial trace, axial trace, axial trace. Connect up all the axial traces here. I kind of missed one of them there. And this is the axial plane. Notice the axial plane is rotated, so it should be vertical if it's upright, but it's not. It's been tilted over like this. So that means we have an asymmetric fold. Okay? We have an asymmetric what? What kind of fold? Where the limbs dip away from the axial plane. So it's an asymmetric anticline. This fold is interesting. It's a huge fold. You can see the Earth's surface here, and it's been eroded through to create a really dramatic side view or profile. This is again a vertical slice through the Earth's crust. We call that a cross section. The red line that I've drawn here already in the PowerPoint, that is the orientation of the axial plane. This particular fold is called recumbent because the fold plane is laying on its side like this. The axial plane is laying on its side, right? Excuse me. So it's really been sheared or pushed over. It used to be like this if it's upright, and the whole thing has been rotated over, something like that. Now, we can have folds that are upright, we can have asymmetric, we can have overturned, we can have recumbent folds, we can have anticlines and synclines, and then we can also have plunging folds. And in a plunging fold, you'll see on the left-hand side here, we get a fold in which the axial trace is horizontal, right? Like the strike line, the axial trace is horizontal, parallel to your tabletop, to your floor, to the water surface of water, like ocean or like Michigan, however you want to think about it, glass of water sitting on your desk. Plunging fold, the axial trace is tilted. So take a piece of paper, take a binder or a notebook, something you have in your hand, fold it over and just make a fold like an arch, okay? Hold it horizontal so you can find the spine of the fold, find the axial plane of the fold, and then tilt it and slice it horizontally. And what shape does it make? Well, if you were to tilt it, that folded paper, and then cut through it, it makes a U shape. if you hold the paper so that the axial surface or axial trace is still horizontal, as in the left-hand side here, and cut through it, right, instead of cutting through here, here you make a U shape at the surface. Here you make two parallel lines at the surface. And so folds are rarely always upright. They're commonly plunging. And this is just another sort of geometry that we see. Okay? All right, so let's just do a little reviewing. Okay? At the surface here, then, we'll kind of work backwards. If we looked at an upright fold at the surface, we would see a map pattern that looks like this. Okay? Upright, parallel lines that have been folded over. I'll draw a symbol in here. We'll call this the symbol for an anticline. I'll put in a bed dipping this way and a bed dipping that way. If I had a map view again of a plunging fold, I draw it like this. So this is what the layers look like in map view, like that. Okay. And then if I want it to be a plunging syncline, I want the layers to dip towards the axial plane. The axial plane is there. So I'm going to draw my strike and dip symbols in towards it like this. Okay. I can add another layer in, something like that. So this is upright. I'll just put an up. And this is a plunge. Plunging fold. Okay. Just to quickly review too also the concept of anticline and syncline. If I was to draw in some folded layers like this and like that, I'll draw in some more like this and like this. This would be a good time for you to maybe take a stab at what you think is an anticline and syncline. So this is the surface. You're standing here at the Earth's surface. Now, principle of superposition says the oldest rock is here, 4, 3, sorry, I'm going to go ahead and erase, well, we'll just leave it 3 and 2, 1, we'll call that one 0. Okay, so here is my axial plane. In a anticline, the rocks, wow, that was abrupt. Let's try that again. In the anticline and syncline, the ages of the rocks become important. So we know that if we draw the axial plane here, and here, these layers dip away and dip away from the axial plane. So this has got to be the anticline towards the axial plane. This is the syn, right? And then this is the anticline here. But the other thing I wanted to point out was rock layers, and now I have a chance to reorder. 1, 2, 3, 4, we'll call this 5. Okay? If I'm here and I walk from 3 out this way, I hit 5. 5 is younger, right? So I go from old here to young here, or from old here to the left, and I walk away from the axial plane, I'm young out there at 5. Okay? If I go from the axial plane in a syncline and I walk away, I go from young rocks, and what happens, I get older, so by this time I'm in 2. Okay, I started in 5, I walked away, and I'm now in 2. Same thing if you're at the Earth's surface, which is, you know, where you would be up here. And then, so I'm old here at layer 2, I'm old, and now I'm walking away, and I'm going to hit layer 4 out here, which is young, so I go from old to young. Okay, so basic overview of anticline and syncline, the age relationships, and the dip values. Don't forget to think about also the overall geometry, upright, overturned, asymmetric types of folds as being important. And at most folds, right, begin with compression, but as they get older and more warped and rotated like this until they become recumbent like that, right, you get shearing. So they start with compression, and then with time and continued deformation, shearing becomes more important. So that wraps up for our discussion of folds.